Hi Jasmine, this is a topic that I noticed you were working on, and this one is a really tricky one, so I wanted to give you some examples to go with it. So this is quotient rule, meaning that we've got fractions here or division, and we have negative exponents. And a negative exponent isn't really like a negative value. It's telling us basically to flip that part of the fraction. So if we see something like y to the negative 2 and it's in the numerator, if we want to make it into a positive exponent, we need to move the y squared down to the denominator. And so what that will look like is in the denominator we already had a y, and then we're going to have another y in the denominator with a squared on it because we moved the y squared to the denominator, and it's now a positive 2. Now in the numerator you do need to have something, so there's still a 1 up there. Okay, now the other thing is that y times y squared, if you wrote it out, it would be y times y times y. Remember, y squared is y times y. So that's 2 y's right there, and there's 1 right here, y to the 1, and so in the denominator we now have y to the third power. Okay, so that's how you basically move something to the numerator or to the denominator if it was in the numerator. Now let's take a look at this one. This one, they both have negative exponents, so it's like this y to the 9th needs to come up here so that it will be a positive 9, and y to the 5th needs to go to the denominator. They need to switch places basically. It's more like the y to the 9th is going to move to the top and the y to the 5th needs to move to the bottom. So we're going to have y to the 9th and y to the 5th down here, and then we need to simplify. Sorry about that. And so then when we simplify, if you think about writing it out, you'd have 9 y's in the numerator and 5 y's in the denominator. So 5 of them would cancel out in the numerator and denominator, and you're left with 4 extra ones in the numerator. You're basically doing subtraction with the exponents. You end up with y to the 4th over 1, or just y to the 4th because you don't need to write it over 1. Okay, so that's that one. That one ended up in the numerator at the end. This first one, we had our answer in the denominator because that's where we needed to be with that first, with the numerator being moved down. Okay, let's try this last one. So on this one, the only part that has a negative exponent is this p to the negative 7. So that expression needs to move to the denominator. So in the denominator, I'm going to have p to the 9th still, and I'm going to have p to the 7th, and it's a positive 7 now because I have moved that expression to the denominator to take care of the negative exponent. And I still have a 1 in the numerator. Remember, you need to have something left there if you move everything out of the numerator. In the denominator, we have multiplication of like bases, so we add the exponents. And the reasoning for that is if you wrote this p to the 9th out, you'd have 9 p's being multiplied together, and then you'd have 7 more p's being multiplied together. So altogether, that's 16 p's being multiplied in a row together. So p to the 16th in the denominator there. And that's the final answer for that one. Okay, so I hope this helps. Let me know if you need more examples or any other kind of problems about exponents, rules of exponents, quotients, negative exponents, that kind of thing. But good luck!